Head Department of Science and Agricultural Chemistry, distinguished staff members, my dear students, and those who are present in the online. Good afternoon to everybody. I am very happy to say some of research findings where we have done at IHR, the soil changes following long-term conservation horticulture practices. So first of all, what is conservation horticulture? You might have all heard that conservation agriculture. This conservation horticulture is it is a management of soil health in the perennial horticulture crops reasonably over a long period of time. So if conservation horticulture practices mainly, we are addressing in only perennial crops. Orchard trees normally grow in one place and produce for more than 50 or 100 years. So orchard soil health is very, very important. This conservation horticulture centers around a floor management or soil health management in orchard crops. So now on the other hand, intensive chemical based orchard system where we use very high dose of chemical fertilizers and frequent plowing. This is nothing but intensive chemical based. It has got some drawbacks, mainly the productivity decline over a time and the cost of production also it's very high and the poor quality of the produce as a resultant of very high doses of pesticides, fertilizers. Due to that, nowadays we are thinking of conservation horticulture or conservation agriculture. So I need not emphasize about the importance of soil health in this gathering. So we are all soil scientists only. You can see some of the fascinating facts about the soil. Whatever the agricultural production, including meat, milk, and fish from aquaculture, everything comes from the soil only. So about 90% of our food comes from the soil. So for that purpose, healthy soil is the key for food security and to achieve the nutrition to all. And it is very well known that there are more microorganisms in 1 tablespoon of healthy soil than there are human population on the earth. And even if you see that soil is the very good sink for carbon, and approximately 10% of the world carbon dioxide emissions are stored in the soil. And recently, the United Nations of Food and Agriculture Organization, they have estimated that more than 50% of the world's agricultural soils are already degraded. So our planet is in crisis. And even that soil scientists will be knowing very well that even to form 1 centimeter of soil, it takes minimum 100 to 10,000 years. And an average, it takes 1,000 years to form 1 inch of the soil. But this inch of soil can be destroyed even in minutes due to erosion. Due to rapid urbanization, in every 1 hour, the good fertile soils have been converted into big buildings. So it has been estimated that 11 hectares of the soil we are losing per hour due to urbanization. If this soil degradation continues, if we don't take any proper measures, then in 60 years, we'll be left without any cultivable soil. We'll be losing all fertile soils in the form of erosion, losing topsoil, even organic matter, these things. So already our soils are in danger. So recently that World Economic Forum, it reported that 800 million people, they're already suffering from hunger and food production will further fall by 30% in another 20 years if we do not take proper soil health management measures. So that a sustainable soil health management is very well required. So even this sustainable development goals, this is also set by United Nations Food and Agriculture Organizations. These are the updation of that Millennium Goals. Even in Millennium Goals also, soil health management is one of the criteria. So that Millennium Goals we have already completed in 2015, and then 2015 to 2030, again they have set some goals, 17 goals. To address these 17 goals, there are several activities. If you see that out of 17, the Sustainable Development Goals, 11 goals which were shown in that green font, almost all connected with soil health management only. Even to address even poverty, zero hunger, good health and well-being, and even gender equality, clean water, sanitation, almost all are directly and indirectly connected with the soil processes and even rehabilitation of soil health management only. And recently you might have come across that one land degradation neutrality. In that also, Prime Minister has taken the pledge that even by 2030, we have to brought even 26 million hectares of this wasteland under cultivable land. So for that also some measures are going on national level. So why soil degradation is happening? The major degradation is mainly due to the erosion. Erosion is nothing but loss of topsoil due to water and wind. So this erosion itself is a major degradation process. In that we are losing almost 75.86 million hectares of the land Due to water erosion, 12.46 million hectares of the land due to wind erosion. What is the total geographical area? Any students can tell what is in India? Three. I'm asking students. 328.7 million hectares. Out of this 328.7 million hectares, more than 30% of the land is under degradation. That is 121 million hectares land. So there is wide range. Even some people have given even 146 because of the methods what they have adopted. NBSS LUP they have given one figure, and even National Academy of Agricultural Sciences. So overall we can consider 120 million hectares of the area is under degradation. This area is very well responding for all management measures. So in that, if you see that erosion is a major problem. So every year we'll be losing billions of soil due to erosion. So in that process, it is estimated that we'll be losing about 0.8 million tons of nitrogen, 1.8 million tons of phosphorus, and 26.3 million tons of potassium due to erosion process. This much NPK will be losing annually. So this recently this one that Space Application Center in 2016 they have estimated what are the states under degradation. So out of all states, Telangana, Madhya Pradesh, Odisha, Jharkhand, Karnataka, Jammu and Kashmir, Gujarat, Maharashtra, and Rajasthan. These are the states where the threat is more than 26% of that degradation is happening in these states only. Other states you can say that 1 to 5%, but degradation is very, very high in these states. So when soil loss is happening due to surface runoff and all, the main threat is loss of organic matter. Organic matter we know very well, it is considered as black gold also because of its influence on physical, chemical and biological properties. So it is a repository or it is a bank for all soil nutrients. When we are losing soil organic carbon, that indicates the soil decline or degradation quality. So knowing the importance of the soil organic carbon, even in 2015 in the Paris Agreement, India has pledged that we will be increasing that organic carbon levels. To increase the organic carbon levels, we'll have to reduce or bring down the greenhouse gas emissions. Whatever that greenhouse gas emissions are there in 2015, it has to be further brought down to 30 to 35% by 2030. For that, we'll have to increase the carbon sink. How much we'll have to increase the carbon sink? 2.5 to 3 billion tons of carbon dioxide we have to increase by 2030. So what are the strategies government imposed? You can see that. Have you heard this one? 4 per milli. That means 4 per thousand or 0.4%. So every year we have to increase the organic carbon to the extent of 0.4%. For increasing the organic carbon, what are the different management strategies? It has been worked out even in fruit crops, annual crops. So how this figure arrived? If you see that that annual world global carbon emissions are 8.9 gigatons, but whatever the carbon stores available in the soil is 2,400 gigatons. The ratio of this only 4%, 4 per thousand or 0.4%. So every year we'll have to increase 0.4% of the organic carbon to address this one. What is that? To increase our global, reduce the greenhouse gas emissions intensity by 35% of by 2000. So to address the soil health, there are different systems of farming. In this, one is low input sustainable agriculture, conservation agriculture, organic farming, natural farming, zero budget natural farming. Every system has got its advantages and its own drawbacks also. But this organic farming and all, one way it is good, but only thing it will not sustain the yield for entire population of the world. Conservation agriculture is the one where we will be conserving the resources and at the same time we will be applying even nutrient doses also here. So the conservation agriculture works mainly on the basis of three principles. So one is minimum soil disturbance. For minimum soil disturbance, there should be no tillage or minimum tillage. Then permanent soil cover. Soil should not be left as such. Always should be covered with green. Either it is live plants or even dead residue. And always it should be rotated with the crop rotation. Why we suggest crop rotation? Even to decrease the pest disease suppression, even weed for that purpose only. So that pest cycles and all, it can be reduced. So the aim of the conservation is conserving, improving and making more efficient of natural resources like soil, water and biological sources along with nutrient doses. That is the aim of the conservation agriculture. Conservation agriculture is practiced mainly in USA, China, South Korea, Canada. But in India, still it is in infancy stage only. But if you see that in a global level, 1 or 2 countries are following this conservation agriculture. Almost in an area of 205 million hectares, covering 15% of the entire area in the world is practicing this conservation agriculture. So here you can see the means and main practices to address each principle of the conservation horticulture. In case of conservation tillage, what are whether you can go for a no tillage or minimum disturbance of the soil. Minimal disturbance means you can plow the soil up to 0 to 15 centimeter depth. Even natural farming also it is allowed 0 to 15 centimeter depth, disturbing the soil, even for sowing the seeds under. In case of a perennial horticulture crops, we can go for only 0 tillage only. You need not even go for any plowing. And then second one, crop rotation, soil cover. These three are the basic principle of any conservation horticulture. So even that conservation agriculture, it will improve the soil health, and even at analysis of conservation agriculture in South Asia at global level, they have given some findings saying that we can increase the productivity level by 5 to 12% over the integrated nutrient management, and water use efficiency can also increase by 10 to 30%, and there is a lot of saving in energy. So we are not going for any intensive using that heavy machines and all. No? So a lot of power saving is there, energy saving. Even up to 40-50% energy can be saved. Even labor saving. It is worked on the minimum input basis. So labor also can be saved. And even that profitability enhancement by 20 to 27%. And even further, we can reduce the greenhouse gases by 12 to 13%. The major advantage here is emission of greenhouse gases can be brought down because we are not exposing the soil. When you expose the soil with plowing and under oxidation conditions of organic matter, carbon will be released to the atmosphere. Those things can bring down. And conservation horticulture is not a single set of techniques. Any conservation horticulture is based on the 3 principles. So all 3 principles have to be applied at the same time. If you apply one principle, we cannot call it as conservation horticulture. So this is integrated, all to be applied together in one place. That is minimum tillage, crop cover, crop rotation. This conservation agriculture mainly addresses these aspects like horticulture production. It has tremendous potential to increase the agriculture sustainability by improving the growth conditions of the crop as well as enhancing input use efficiency, and it also improves the natural base. Natural base it improves by building up the organic matter in the soil. When organic matter is more, and even the penetration of water will be more, and even that losses of water due to runoff, it will be reducing so that even we can minimize the pollution of water also. And biodiversity. Biodiversity, because of high organic matter and all, the biodiversity also it increases. Labor shortage. As it works on minimum input principle, labor shortage, because we will not be engaging labor for even plowing of that. So the labor can, they utilize their available time for other operation, the income generating process, some other they can engage their time for processing, even for fishing, even other purposes, so that they can generate some income. And even that climate change, it also addresses the climate change, conservation horticulture. Even in drought conditions, because of mulching effect, we can save the water even to the extent of 30 to 35%. Even under high flooding conditions, under whenever the excess water, even we can avoid the percolation of water or even runoff losses because of this mulching effect. And so that is one thing. It also improves the livelihood of the farming community. Even soil, it can act as both ways. It can act as source for carbon dioxide. It can act as a sink for carbon dioxide under different conditions. When soils are very light textured and you are going for only annual crops and with intensive tillage, then soil can act as a source for carbon dioxide. It will emit a lot of carbon dioxide to the atmosphere. When we are going for only minimal tillage and even that soil also like texture clayey with less tillage, then it can act as sink for carbon. So some of our experiences in conservation horticulture in mango orchard, just I would like to share. So what are the impacts of this conservation horticulture on especially soil properties? So in Indian Institute of Horticulture Research, we have conducted one experiment in mango orchard only. There we have gone for 4 distinct management practices. The first one is mango orchards clean cultivation and intensive management. So here every year, frequently it will be cultivated mango orchard. And second one is mango orchards and weed cover intensive management. It will not be disturbed. Whatever weeds, it will be left as such only. And third one is mango orchards under conservation horticulture practices. Conservation horticulture practices means we have not gone for any tillage And always the soil also covered with some cover crops, and we have gone for intercropping and every year crop rotation. That one. And fourth one is to compare these effects. We have taken one vegetable field also, which was under continuously under cultivation intensive cropping. Yearly 3 vegetables was taken. So all these 3 management practices were seen. Here you can see that the first one is mango orchard with cover crop. Here mucuna was taken as a cover crop. Mucuna is very good in nitrogen fixation. It adds lot of biomass, and nutrient cycling is also very high in case of mucuna cover crop. And the second is mucuna with pumpkin. So every time we are going for not only mucuna, crop rotation also. Some intercrops like cowpea, legume crops. Then sweet potato also tried. Why sweet potato? Means sweet potato is very good in biomass production and almond. It may be disturbing somewhat with the roots and but the biomass production is very high. The sweet potato also it was taken. And here you can see that mango orchard under clean cultivation. So frequently ploughing with heavy machinery and mango orchards with crop residues. Even if you don't have live also, you can bring it residues from outside and it can be kept. Then mango orchards with grass cover, weed cover, and this is vegetable plat under continuous cultivation. And in these 4 distinct management practices, we have evaluated the effect of conservation horticulture practices and soil chemical, physical, biochemical, and biological properties after 6 and 9 years of treatment imposition. So here you can see that bulk density, the effect of bulk density was very, very conspicuous in surface layer. In case of vegetable plat, that is bulk density almost 1.39, it was drastically reduced in case of conservation horticulture practices. After 9 years, you can see that almost 0.38 gram per cc, that much difference was there in case of conservation horticulture practices, because the soil compaction was less in case of conservation horticulture practices. And then next one was conservation horticulture practices with weed management. To some extent, it was better. But these two are under highly vulnerable conditions: continuous vegetable plat as well as continuous cultivation of mango orchard intents. Then here also you can see that post-harvest soil profile moisture. In case of conservation horticulture practices, after 9th year, it was like 51.18 centimeter. In case of 150 centimeter profile depth, when it comes to vegetable plat, it exhausted almost all the nutrient water content in the profile moisture because of its exhaustive cropping system, and it is even 38.2 only, that much low. Similarly, that the mean steady state infiltration rate. The conservation horticultural practices have significant influence on this steady state infiltration rate. It was almost 388 after 9th year of imposing the treatments, but it's not even 50%. It is very less in case of vegetable intensive cultivation plants. And even that aggregate distribution. Aggregate distribution, it was done under different systems, and that aggregate stability steady increase was more in case of conservation horticulture practices. Here you can see that after 9 years, in case of dry aggregates, it has increased from 84% to almost 118% in case of conservation horticulture practices. Then in case of vegetable plat and continuous cultivation of mango orchards, a drastic reduction happened, even from 6th year to 9th year. Aggregate stability. This increase, this changes was proportional to the glomalin content. Glomalin is nothing but that fungal protein which is responsible for aggregate formation and maintenance of stability. So if glomalin content is more aggregate formation will be there, and even stability also it will be more. And we have also estimated the soil organic carbon fractions under these distinct management systems, and even that the loss on ignition and organic carbon were significantly higher in case of conservation horticulture practices. Even at 9th year, you can see that it is loss on ignition was almost 14.54% in this gram per kg. In case of vegetable plat and intensive management plats, there was a drastic reduction. And even that soil active carbon mineralization rate can be seen here. Soil active carbon and the soil microbial biomass, these are the fractions of organic carbon which are very small in organic carbon, but they are very, very dynamic in nature and are easily influenced by management practices. And even that soil active carbon under the conservation horticulture practices, you can see that significantly high. It is almost 52.8 milligram per kg soil. And when it comes to the vegetable plat and the intensive mango orchards, it's only 18.06 and 16.36 milligram per kg. It was proportionately influenced by the mineralization rate. Mineralization rate is drastically reducing in case of conservation horticulture practices. Then the another fact is the soil microbial biomass carbon. It is only 2 to 3% of the total organic carbon, but it's very important for nutrient cycling point of view. Even you can see that conservation horticulture practices, this value is also very high, almost threefold higher in case of soil microbial mass under conservation horticulture practices. But again, that intensive cultivation, there was a drastic reduction. Soil chemical properties, mainly that in case of vegetable plant, we observed acidity because of continuous cultivation of these fertilizers and in case of conservation horticulture practices, all exchangeable cations increased, but that even that pH also comes to almost neutrality. And even available nutrients, there was no particular trend under specific trend we could not notice because the available nutrients mainly based on the application of the inputs. In case of vegetable intensive cultivation, the doses were very high, so it resulted in higher available nutrients. And we also estimated the soil microbial population and its diversity under the different management systems. Even you can see that bacteria population is very high in case of vegetable intensive cultivation plant compared to fungal population. In case of conservation horticulture practices, that fungal dominance is there. When fungal population is more, even that decomposition of residues will be faster and nutrient cycling will be more. So that clearly we have noticed in case of CHP practices, but fungal population is very low in case of intensive cultivation of vegetable plant. And even that the impact of this conservation horticulture practices and after 6th and 9th years, that studied on even extracellular enzymes like dehydrogenase, urease, phosphomonoesterase, aryl sulfatase. Because of high organic buildup in conservation horticulture practices, even that enzyme activity is also very high. And even the soil faunal activity, you can see that that earthworms and centipedes almost absent in case of vegetable system and high intensive mango orchards because of continuous cultivation, and that shows loss of soil health, even degradation of soil. And even the same systems, we have gone for soil carbon sequestration studies because soil carbon sequestration is one of the mitigation options for climate change. So conservation horticulture is the best option even for sequestered carbon. With that idea, with that hypothesis, we have studied even the effect of these management practices and soil carbon sequestration. So carbon sequestration is the removal of carbon dioxide from the atmosphere and storing it in the soil through photosynthesis. Horticulture are the potential crops for, especially perennial horticulture crops are the potential crops for the carbon sequestration. Because it biomass, if you see that almost 25 to 100 times higher than annual crops, and trees are also having deep rooted crops. Even almost 29% of the above ground biomass is equal to root biomass. So more of that carbon also fixed in that roots. In any carbon sequestration studies, first carbon will be studied in different pools like horticulture crops. What is the carbon sequestered by above ground biomass, below ground biomass, deadwood litter, and soil organic matter. Based on these pools, we will sum up and will express in the terms of total carbon sequestered by the plants or tree. Actually, that for many horticulture crops and all, people use forest equations for working out the carbon sequestration potential, madam, but that is not correct. Nowadays, we are using only graphs only. So, for forest equations means we have to take one allometric data, that is the diameter at breast height. So, that is minimum 60 centimeters. For graphs, we don't get that immediately, that the branching will start at ground level itself. So, for this, at IHR, some work is going on, development of allometric equations to work out the this ground biomass. So in that allometric equations already worked out for mango using the power function model and all. Based on that equations only, we have taken some allometric data and we put that equation, worked out that ground biomass. Here you can see that using that allometric parameters, we have worked out for allometric parameters, we need only two parameters to work out the biomass. One is number of primary branches and another one primary branch girth. If you know in orchard crops, these two parameters, based on that we can fit into equation and we can get above ground biomass. Once you know the above ground biomass, again 1 is to 0.9. So one part of that above ground biomass, 0.29% of the root biomass. Accordingly, we can convert what is the root ground biomass. Then that weed litter, leaf litter also will have to work out in the orchard for square meter area. Annual, how much litter we are collecting, what is the weed intensity. Once you know these four parameters, then finally soil. So profile wise, 1 meter depth, what is the organic carbon stock we are working out. Then summation of all these 5 pools is nothing but total carbon sequestration in orchard. Like that we have worked out. Here you can see that in case of conservation horticulture practices, total tree carbon 30 tons per hectare. But vegetable, there is no carbon sequestration under almost all. No, whatever we are destroying the plants only vegetables, we cannot work out. Only whatever carbon sequestered by soil is, that is the total carbon sequestered in the vegetable system. That soil carbon stocks. Soil carbon stocks are more than 15.6 tons per hectare higher in case of mango orchard under conservation horticulture. We can see 75 tons per hectare. Mango orchard. In case of vegetable blood, it is very, very low, only 60.5 tons per hectare. So like that, under different pools, it has been worked out. So total carbon sequestered under conservation horticulture practices was 107.63 tons per hectare, whereas it was in a vegetable system 60.5 tons per hectare. So cutting across the different management strategies, we can tell that mango orchard sequestered 1.68 fold higher than vegetable system. And even that Chittoor is it is a biodiversity spot for all mango varieties, and then there we can find even more than 1,000 varieties mango. So in that we have taken one pilot study only. Is there any difference in carbon sequestration among the varieties? So there we have gone for monovarietal and multivarietal orchards. Monovarietal is only Totapuri dominated one, and multivarietal in each farmer is having more than 10 varieties in his field. So like that we have estimated, but there was no difference varietal wise. So almost all it is sequestering same amount of carbon. That much only, madam. This is the little piece of work what we have done at IHR. It is not any reviewing work and all. So I could not do much justice to the last moment only I made it. And, thank you, madam, for giving an opportunity just to share whatever we have done. Madam, dry aggregates, it was more only that impact and all. Wet aggregates, not much. Actually, dry aggregates, it was showing more only. Even it was done at NBS LUP, madam, this piece of work. IHR, we don't have facility, but they also expressed that dry aggregates impact, it's it is giving more like. This equations only for Goa only, madam. Like that for other crops also we are trying that. For development of that equations, first you have to collect voluminous data. Suppose you think of that mango. For mango, we have to go for different age group, starting from 1 year to 100 years, like that it has taken. In that, what is the plant height, what is the canopy spread, what is the volume. Then we have to go for first destructive sampling only. For development of any equations, first step is destructive method. Once you develop the equations, then based on non-destructive method only, we can work out the total biomass. Initially, for developing of equations, you have to go for destructive method. For destructive method, you have to generate lot of data. What is the diameter, height, girth, canopy volume, based on that biomass expansion factor. Based on that only we can work out. Once it is like that for other crops also, now it is going on. Sir, to call it strictly carbon sequestration means whatever carbon stored or locked in the wood, that is the carbon sequestration. We are simply misusing that term. Vegetable system, it will not come. Suppose this is wood stored, this is real carbon sequestration. Suppose any tree you are cutting, again burning means again you are releasing this greenhouse gases in the atmosphere only. So that is not carbon sequestration. It has to be locked in the wood, permanent structure. Then only we can call it as carbon sequestration. To work out only we are doing that exercise under, but vegetable system you may be removing that one. Again, if you incorporate the residue, it will add some organic carbon. Many people are not even incorporating that, removing outside, or even for management of point of view, some people are going for burning, all those things. Again, it is emitting only rather than sequestering, it is emitting more of greenhouse gases, carbon dioxide. So for that, carbon sequestration means whatever locked in the wood system only we can call it. So for that, even mango, even sapota, rubber, these crops are very good candidate crops. Even that grapes, roots are also very hardy. That also good carbon sequestration crops. Once it is stored, or nowadays people are even recommending biochar also. Why we are recommending biochar? Once now high density planting is common. No, high density planting to contain the canopy, you have to go for frequent pruning only. Once material is pruned, you have to go for composting. Hard material and all you cannot go for composting. No, very this one wood type material. That at least you can go for biochar, and you can apply to soil, at least to enhance the carbon levels. That is IHR, that now that in situ composting and all, no, it's microbiologists that are doing that one. Nothing is going waste, whatever they're collecting, no? Even that Arca decomposer one technology is there, using that one, the decomposing the plant material. Because if you see that soil are good reservoir for soil carbon, 2 to 2.5 fold higher in case of soil. Soil is a good reservoir for this. For that only nowadays people are promoting conservation agriculture, conservation horticulture. See, some people think that clean cultivation is the best. Clean cultivation means nothing will be there every time plowing. It is easy to manage. Even still some farm. Yes, madam. Even our IHR also, one group of people always they keep it clean, very clean field. That is their one concept. Continuous pesticide spray, all those things, it will be conservation horticulture we have seen. You need not spend anything, just leave it as such. But after certain years, madam, lot of biological activity, even microorganism population, everything it is high only. It is like working in harmony with the nature. Microbial consortia, it is available, madam. That microbiology group, you have a division only. Even one Arca decomposer is there. That is 5 kg per ton of that produce, whatever that it is recommended. Now it is working well only. Arca decomposer, even that our division is in forefront in development of several products also. Dr. Selakumar will be coming here this month only for Viva something. He has developed a lot of products. That AIMS, it has become so popular. One Dr. Panis Selvam, now he is in Rice Institute. That is one single inoculum. It's carrier-based inoculum. In that nitrogen fixing, P solubilizer, zinc solubilizing, madam, and many PGPR, plant to promote regulators, it is there. So with that, we can save even 25% of NNP. That's what they're claiming. But now all India level ASRP trials also it is going on. And one more thing also, foliar one, so far we don't have that also now they're working, that methylotropic bacteria. That also more aggregates, sandy loam soil. For aggregate formation, you need anything, no? Like, no, organic matter is required or clay content, even to aggregate together. Only sandy clay, even Rajasthan we have seen, it is like only particles only, no aggregation in that. So for that, organic matter is required. You have to apply liberal application of manures or green manures you can grow. So once you incorporate sufficient organic sources only, then it will develop aggregates and all. For that only that glomalin content we showed, no? Fungal. When organic matter is more, it will act as food material for microorganisms, no? Then release of exudates